Alright, so sorry for the mic static. I'm still messing around with stuff to try and reduce it. I don't know how to prevent it in the first place, so I'll probably just get a new mic eventually. But we're learning. This is a learning process, so. Welcome to doing my AP Calc homework. For summer school. It's not really summer school. It's just getting ahead of the game. And I've got some coffee that I made at 9 a.m. and it's 11 a.m. and I've taken like 2 sips of it. So I did indeed watch the video. So one is A. Everybody, you can copy off me if you want. Alright, so as x approaches -1, the function of x approaches 3. Isn't that cool? So that'll be A as well. Not really any work to show, so just writing it down. As x approaches 0, the function of x approaches 4. Well, actually, no, because limit doesn't. It's not. Yeah. So even though the point at which 3 is on y the first time is not included in the graph, it's teleported 2 spaces up. The limit is not responsible for where it is, it's only responsible for where it's approaching. So it doesn't matter if it's a point included, a point not included, or a point way somewhere else, away from the line, away from the function. So just second guessing myself, but we're clarifying. So as x approaches 2, the function of x approaches, gosh, I have to count. Why am I counting? 7. That's a 7. 7 spaces. Same rule. That'll be D for 7. Number 5. As x approaches 5, the function of x approaches. So this is a fun one. No, it's not. It approaches. I have to count again. 5. It's 5 and 5. Not fun. Alright. Number 6. As x approaches positive infinity, I'm not even sure, but y approaches negative infinity because it's going down. It's perpetually going down. I mean, it could reach like an asymptote, but it's not indicated. So we're gonna go D for 6. Still no work to show, but now we are doing... Oh boy. Did you want to remember trig functions and logarithms? No? That's too bad, because we're doing this right now. So we need to find the limit of a log function where... Alright, not a common log. The log of base 2 gets to x. So if x is 16, then the log of base 2 equals 4, much like the exponent 4 on a 2 would make 16. Of course, we're not visualizing this, we're just plugging it in the equation. But that's how it would look on a graph as well. 8. Good thing that's the only log question, because I just... When x is at 7 pi over 6 radians, which is to say 210 degrees, the cosine finds itself not only negative, but at the ratio of 1/2. Making it B. The answer's B. And I could double check myself. I probably should. I'll do it later after the video. This is a video. Why am I doing it? So, the precedent for this is that we don't have anything to upload today. And I need to do actual stuff, and Brian's in actual summer school, taking like a VR AR course, because that's cool as hell. And, oh, speaking of which, we're gonna record some VR stuff. So, we'll look at that. And so I need to do actual stuff, and I also need to record, and I might as well. So number 9, this is a cotangent. This is an inverse tangent when x is pi over 3. God. It's not an inverse tangent, it's a reciprocal of a tangent. I don't know why I said that. Because there's actual inverse stuff, which is I'm gonna cry. So, pi over 3 radians, which is to say 60 degrees. A tangent would find itself at square root of 3. Yeah, square root of 3. Yeah. Over 1 if you want to be that way. So that means the cotangent would be 1 over the square root of 3, and then we multiply that out to be square root of 3 over 3, because you don't want a square root in the denominator. So this answer is D. I'm stressing a little too much. Just gotta refresh my memory. Okay, so that's where the limit is. I mean, graph-wise, yeah. Limit as x approaches 5 pi over 6 cosecant of x. Okay. Oh, I have a message on Discord. Isn't that fun? So 5 pi over 6 radians, which is to say 150 degrees. The sine of x would be a positive 1/2, meaning the cosecant, the reciprocal, would be a 2, making that a. Alright, as x approaches pi, secant of x approaches what? Pi meaning 180 degrees, pi radians, 180 degrees, and so the cosine would be negative 1 at 180 degrees at pi radians, and the reciprocal of negative 1 is negative 1. So doesn't that work nicely? Making it C. 12. X approaches 0.5. So we'll call this 1/2. It's just trying to make you stupid. Make you, you know, It's just trying to catch it. So 0.5 or as expressed as 1/2. So the inverse functions are basically what we're doing, except instead of plugging in like a radians and getting a ratio, you plug in a ratio and get a radians measure, which wouldn't make sense normally because that's not a function. There'd be multiple radians measures for one ratio. An inverse trig function is limited anyway, so cosine is limited to the range of 0 to pi radians, whereas a sine or a tangent would be limited from, you can have negative pi over 2 radians to pi over 2 radians, so basically, yeah. So in that range of just 0 to pi, the only 1/2 ratio that a cosine finds is at 60 degrees. Because everything above 90 degrees would be negative, and anything below that would be out of the range. So pi over 3 radians is B. We got 3 left. Three more limits questions. So 13. Another 1/2. Arc sine, inverse sine, same exact thing. Just another different way of saying. So when we have 1/2 for sine, we have pi over 3 radians, except no, we don't. Negative 1/2. Negative 1/2 of sine. Wait a minute. This is way out of the range. This is way out of the range. So we'd need to ignore B and C. Am I getting it backwards? No, I'm not getting it backwards. So pi over 6 and negative pi over 6 are the only ones in the range. Oh my god, am I thinking... Hold on. I might be confusing pi over 3 and pi over 6 radians. That'd be stupid if I was. Pi over 3... No, I did that right. Alright, okay, I'm just, here we go. This one was pi over 3, right? Yeah, okay. I'm not being confusing. So this will be negative pi over 6. Because that's the only measure for negative 1/2 within the range of inverse sine. The only measure for 1 within the negative 1 within the range of inverse tangent would be negative pi over 4, the equivalent to 315 degrees, or minus 45 degrees from 0. We have one question left. The only measure, I am phrasing these differently every time, but it's just helping me work it out. The only measure of negative 1 in inverse cotangent. Alright, so inverse cotangent is fun because unlike inverse secant and inverse cosecant, where it keeps the range of its reciprocal, inverse cotangent switches the range. It doesn't keep the range of tangent. So inverse cotangent is now the same as cosine and secant would be, where the range is 0 to pi. So we can automatically rule out D. So we need a measure for negative 1, which means we'll have to go above 90 degrees, above pi over 2 radians, but not past pi. So that'll be I'm second guessing myself because of the reciprocal though. So it would normally be 135, but I mean even if I have to do some reciprocal stuff, it would -1 would be the same. Its reciprocal would be the same as itself. So I'm just gonna wing it, and we're gonna go none of these. None of them. We're gonna go none. I almost had a breakdown, and then I realized that E is an option. Okay. So this is we're just doing the first section. I'll do section 2 and 3 later. Just for each different videos. I didn't have to show any work today, but I will later, and that is not now. So thanks for watching me do my homework. And we'll see you on a day where we have recording material. we're out of stuff. I mean, not really. There's a VOD to upload that's taking forever to render because it's like a 6.5 hour VOD. It'll take even longer to upload, I have no doubt. But yeah. Okay. I'm ending it. Bye.